Hello and welcome to Theory 4. In this short lecture, I'm going to introduce atonal pitch class set theory, and particularly 5 ways of accounting for pitch class structure. It'll be rather technical, but you can always stop it, rewind, ask yourself what in the world I'm talking about. So the first thing I want to tell you about are pitch class numbers. And knowing these cold is totally important for your theoretical health for the rest of the class. Composers we're going to be studying had no idea about pitch class numbers. They just wrote notes and talked about notes like C sharp and D flat. Theorists in the 50s realized that it would be really nice to figure out a way of referring to those notes, those pitch classes, without their tonal baggage, right? A C sharp sounds like it's in D minor, it's a leading tone that wants to go up. D flat sounds like it's in F minor and it's flat 6 that wants to go down. So instead, they being set theorists, notes as pitch classes by number. And that's what we're going to use throughout the course. So for example, here is a representative group of notes as we're used to thinking about them. Right, with enharmonic equivalents. So all C naturals, B sharps, and their enharmonic equivalents are pitch class 0. C sharps and D flats 1, D natural 2, D sharp, E flat 3, E 4, F 5, F sharp and G flat are pitch class 6, G is 7, G sharp, A flat is 8, A is 9, A sharp, B flat is 10, and set theorists like having a single character for every number. So T for 10, I'm sorry, and E for 11. So you've got to memorize this. So if you think of a G sharp, I want you to think of pitch class 8. Right? These are the pitch class numbers. Pitch class numbers. Now, just as notes need to be cleansed of their tonal implications, so do intervals. So there are 4 ways of talking about intervals in atonal pitch class set theory. Let me talk about those notes. Pitch class 5, 4, 0, 9, 7, 2. I'm going to show you the 4 different ways of talking about the intervals between this note and this note, 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 and between this pitch class and this pitch class and this pitch class and this pitch class. So notice I talked about pitches first and then pitch classes. There are 2 systems of talking about pitch intervals and 2 systems of talking about pitch class intervals. When you move from the first one to the last one, you're moving exponentially into orders of abstraction. The first intervallic structure is very close to the piece, to the actual sounds that you're hearing. The next one's a little further away, and then this one's really far away, and this one's from outer space. Right, so thinking about Google Earth, if these were houses, the first level, you'd be able to see your house, see the car, see the dog, see the bicycle. A little bit more removed, you could tell basically that your house is on a certain street next to a bigger street that you recognize. Moving down to the third one, you might not see your house at all, but you'd see the neighborhood in relationship to the DFW area. And the last one, you're outside the atmosphere, and you can basically see North America. So the first one is called ordered pitch intervals, or OPI. Ordered pitch intervals is the number of half steps with regard to direction from this note to this note. It's a half step, down a half step, so it's -1. E up to C is an ascending minor sixth, which is +8. 8 half steps. So you have to memorize how many half steps are in the conventional intervals. From C down to A, descending minor third, -3. From this A to this G is a minor seventh +10. 10 half steps. Right, 2 more would make an octave, right? So G, G sharp, and A to A is 12. These are just numbers of half steps. G down to D, -5. And then, the purpose of this is if you had a stream of pitches and you couldn't tell what they were, what function they had, there's no tonality, you can see with each of these filters if there's some order. Here you don't see a whole hell of a lot, except there's descending, ascending, descending, ascending, descending. Okay, maybe that's something. The next is unordered pitch intervals. And unordered pitch intervals is the number of half steps between 2 pitches, regardless of whether they go up or down. Just simply how many half steps. So here we have 1, 8, 3, 10, and 5, right? So you're removing some information. The next one gets a little tricky because these two deal with pitches. The next two deal with pitch classes. So we have ordered pitch class intervals. Now this is a little trippy because what is the difference from any F to any E? Not this F to this E, but any F to any E. Now, the way we're going to think about pitch class intervals is using the clock. Because our numeric system is base 10, which doesn't fit to music at all. But luckily, the way we tell time does perfectly. So we have a little tomato clock here. Now, think of these not as hours of the day, but as pitch classes. C, C sharp, D, D sharp, E, F, F sharp, G, A flat, A, B flat, B natural, C. Ordered pitch class intervals are always calculated clockwise from the first pitch class to the second. So here we have F to E. F is pitch class 5, and it's going to go clockwise to E, pitch class 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? Going from F clockwise to 4 is 11. E to C, clockwise. E going up to 12. E, 1, 2, 3, 4, 5, 6, 7, 8. C, clockwise to A. 12 clockwise to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. A, clockwise to G. 9 clockwise to 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. G, clockwise to D. 7 clockwise to 2. 1, 2, 3, 4, 5, 6, 7. And that, my friends, is how you calculate ordered pitch class intervals. And here you can start to see a little something, even in this little stream of pitches. You've got a 7, 8, 9, 10, 11. Right? There's a kind of orderly accordion-like structure going on here. The fourth one is, guess what? Unordered. Pitch class intervals. An unordered pitch class interval is the shorter distance, clockwise or counterclockwise, from one pitch class to another. So, F to E, 5 to 4. The closer distance is obviously counterclockwise. 1. E to C, 4 to 12. This distance is obviously closer than this one. 1, 2, 3, 4. C to A. C to A. This distance is obviously closer than this one. So it's 1, 2, 3. A to G, 9 to 7. This distance is obviously closer than this one. So it's 2. G to D, 7 to 2. This distance is obviously closer than this one. So it's 1, 2, 3, 4, 5. And that is unordered pitch class intervals. And here you can see a more reduced structure like this one, right? You have a 1, 2, 3, 4, and a 5. So that, my friends, is an overview of pitch class intervals, and pitch class numbers. See you next time.